velocity time curve and acceleration time curve for a particle moving along a straight line. In this segment, we are going to discuss about a particle. For example, say a particle is thrown vertically upward. I am just drawing here path followed by the particle. It reaches at its maximum height at certain time, say t1, and then it returns back to the actual position from where it was thrown after some more time. Particle was thrown from here. Say I am drawing it by a red dot here. This particle was initially thrown with certain velocity, say u. After traveling its path along the straight line, which is vertically upward here, particle reaches at some point, say this one, after some time, say t1. Particle was thrown at time t equal to 0, that's I am considering here. So after time t1, it reaches at this height, say this height is h1. After some more time, it continuously goes vertically upward. Acceleration to which particle is subjected here, it is no doubt acceleration due to gravity. And this acceleration due to gravity, I am indicating it by small g, it is always acting vertically downward. You can say during this upward motion, particle has to face some retardation caused by the gravity of Earth. Say at certain time t2, it reaches at its maximum height. I am indicating it here with capital H. No doubt, when it reaches at its highest point, its velocity becomes 0. Time in which it reaches up to the height, capital H, it is say t2. Again after passage of some time, it returns because here its velocity becomes 0. So it is just like a dropped object which has been dropped from this height h. Now during backward motion, this particle moves in this way. I am drawing the line a little apart, but actually it follows the same path by which it reaches at its maximum height. So if I consider the downward motion of the particle as the separate motion, then it starts falling from this point with initial velocity 0. It reaches any intermediate position at some time, and after that, after the same time in which it rises up to height capital H, it reaches again at the initial position of the particle. Now for this motion, if we talk about the velocity time curve, then what we can say just by seeing this motion, look here, I am taking upward direction to be positive. It is necessary to take some reference about the motion. Here I am taking the reference that upward motion is positive and downward motion is negative. To draw the velocity time curve, you must know velocity is defined as first derivative of position of the particle, means dx by dt. Velocity of the particle is defined as first derivative of position of the particle with time, which can be obtained by taking the slope of tangent to the position time curve. We have discussed this fact earlier also. Now, in case of one-dimensional motion, slope of the curve may be either positive or negative. Means particle may have velocity either positive or negative. What is the mean of positive velocity and what is the mean of negative velocity? Positive velocity means particle is moving in forward direction, means particle is going ahead, while in negative velocity we can say that particle is returning back to its initial position from where it starts. So, this positive and negative, especially for instantaneous velocity, is very much important because sign have the same meaning as if I say I borrowed money from you, say 1000 rupee. It means I have taken 1000 from you. But if I say that you borrowed 1000 rupees, then it means that you have taken it. Now, positive and negative have the same meaning in this context, so always mean it while dealing with instantaneous velocity. Now, we are going to draw velocity time curve for this particle, for which I am taking this coordinate system in which this is the positive x direction and this is positive y direction. Here to draw the graph, we have to take the two variables along this axis and this axis as we have done earlier also. I am taking time axis to be along this x direction. In the positive x direction, time increases, and if we take velocity of the particle, it is taken as positive in positive y direction. Obviously, along the negative y direction, velocity becomes negative. At t equal to 0, particle starts from origin. Say, here we have taken 0 position of the particle at ground itself from where it was thrown. If we talk about the acceleration of the particle, it is opposing the instantaneous velocity of the particle while going upward. So, here acceleration is negative. If acceleration is negative, then obviously particle's velocity goes on decreasing. We can take initial velocity u at this velocity axis at this point where the velocity is plus u. Now, as acceleration due to gravity is a constant acceleration and it is acting vertically downward, which is negative here as per our sign convention. So, for the constant acceleration, velocity time curve must be a straight line, because if we use the definition v equal to dx by dt and acceleration equal to dv by dt, then from acceleration equal to dv by dt, we can obtain that dv by dt is a constant term, which is acceleration here. So, we will get negative slope for the upward motion of the particle for the velocity time curve. So, I am drawing this line with the negative slope. Just consider. Say this is the time when it reaches at its maximum height. No doubt, at maximum height, its velocity becomes 0. So, we have taken it here on the time axis. This time is t2. At some other time less than t2, it was here at height h1. So, I am just taking randomly its time when it reaches it at height h1 is t1. Now, after time t2, as time never decrease, so I am continuing its negative motion in the same curve for the larger times. At some other time, say t3, when particle reaches at the same height h1 at which first time it reaches at time t1. So I am drawing just this corresponding time t3 here. Say after completion of time t4, particle reaches back to its initial position. We can say, because accelerating and retarding accelerations are same, so it again acquires the same velocity but in opposite direction with which it was thrown. So velocity corresponding to time t4, I may take it as minus u. Now, because in this case acceleration is constant, which is g here, so in the upward motion, if we talk about the acceleration of the particle, then it can be achieved by the slope of this line here at time t2. Velocity is 0. At time t2 it reaches at its highest point, so I am taking its velocity to be 0. Then final velocity is 0 minus initial velocity was u. So 0 minus u divided by time t2 minus 0. Here at t equal to 0 we have taken particle to be projected. So the acceleration here for this positive motion, it comes minus u upon t2. Similarly, if we talk about the negative motion of the particle, negative motion means particle has velocity in opposite direction or negative direction, so we are calling it a negative motion. In case of this negative motion, when particle is returning back, if we talk about the acceleration, then see acceleration here becomes final velocity. At that time it reaches at its initial position, it is u, and at the maximum height its velocity was 0, from where it drops now, divided by time t4 minus time t2. You can say that while coming downward, its acceleration becomes positive. Positive means it is supporting the motion of the particle. That's why its velocity continuously goes on increasing. I think by thinking about this curve, we can say that at any instant of time during its motion, what is the direction of velocity, what is the direction of acceleration, and at what time its velocity becomes 0. From the velocity time graph, what are the basic information which we have achieved? The first information which we have achieved here is its instantaneous velocity. The other information which we got from this curve is the slope of tangent on the velocity time curve. It gives acceleration of the particle. So the second thing which we have achieved from this curve is acceleration, which can be achieved by dv by dt, means slope of velocity time curve. The third thing which we may get from this curve is displacement, which can be achieved by taking area under Vt curve. What is the meaning of area under the curve here? As we know that area bounded by velocity time curve and time axis, it gives the displacement. So if any curve is taken of this shape and for the particle, say we achieve this velocity time curve, then for these two then for the time interval between t1 time to t2 time, we can achieve this area bounded by the curve and the time axis. We get displacement traveled by the particle between this time interval t1 to t2. Now these three information can be gathered by just studying velocity time curve. The beauty of velocity time graph is that we can find displacement as well as acceleration of the particle from this curve. So this is very important curve which we will use in solving the questions with constant acceleration.